So hey, hi everyone, welcome to Radhi classes. Today we will discuss the topic sets. I think it will be very helpful to you if you are preparing for some examination like STAT, PGT. So let's start. So what's the definition? So it is a well-defined collection of objects. Well-defined collection. Second, there is no confusion whether a particular element will belong to the set or not. Okay. For example, let A is the collection of all the intelligent students. So tell me if A is a set or not. I will wait for a while and then discuss. So someone of you will say that is a set, but it's not. This is because everyone has different perception of the particular person is intelligent or not. Like Ram, in my perception, Ram is intelligent, but in your perception, Ram is not intelligent. So there is confusion whether Ram is intelligent or not. So it is not a set. Okay. The second example is let A be the collection of students whose height is more than 162 centimeter. If it is an set or not? Yeah, it is a set, because we can measure easily the height of the students. So if those height are more than 162 centimeters, so those belongs to A, and those whose height are less than 162 centimeters, so they are not belonging to A. So yeah, there is no confusion I have. So yeah, it is a set. Okay. So we can define sets through two types. One is set builder method. And the second one is roster method. So in the set builder method, what is the difference? So in this method, we define a definition for an element to be the member of the set. Like let A be the set of the elements 1 2 3 4. Okay, in roster method it is very easy to put the number as it is. So it is a roster method in which every element is listing, and it is very easy for all of us. But in set builder method, we will have to define the by the definition, like x such that in this set, it is the collection of all the x. And what is the property of x? X is less than equal to 4, and x is also a natural number. So we all know, if x is a natural number and also it is less than equal to 4, so it must be 1, 2, 3, 4. So I think you got it. Okay. So now we will discuss the sets, how many types the sets are. Okay. On the basis of their property. So there is a lot of different type of set. We will discuss one by one. So first is null set. The null set is the set in which there is no element. Okay, so we define it by 5. Okay, for example, x is the set, it is a set of elements, like it is a, it is a set of elements. And what type of elements it has? It has an element that x is less than equal to 0 and x belongs to natural number. Tell me if there is any natural number which is less than equal to 0. We all know natural number starts from 1 and it is going on as 1, 2, 3, 4, 5 up to so on. But there is no element which is less than equal to 0. So it is an empty set. Okay. The second one is singleton set. Singleton set is a set in which there is only one element. Okay, for example, one A. So these all sets have only one element. So these are singleton. Third one is finite set. So we all know what is the finite means. Finite means like that is limited. Finite is limited. Also it is a set in which we can list the elements. Like A is a set 1, 2, 3, 4, 5 up to so on and n. Here n belongs to natural number. So what is the main property? So here there is an n which belongs to natural number. So for all the finite set we can easily find an n we can list the finite set. Now we define the order of set. So as we have discussed the finite set, so what is the order of set? We discussed that for every finite set we can find an n belongs to natural number, so we can list all the elements. Okay, so what is the order of the set? So order of the set is the number of elements in that particular set. Or we can say it as cardinality. And it can be represented as Na. That is a cardinality. Okay. So we have now infinite set. So it is a set which can't be listed by any natural number. For example, let A be the set of all natural numbers. Can you list it? Can you list it? If there is any natural number by which I can list it. No, like if you give me like 1 billion, so I will give you 1 billion 1. So for every element there is something which is greater than that element. So obviously it is not an finite set, it is an infinite set. Okay. Now there is another type of element, that is equivalent set. So what are these? So equivalent set are the two set whose cardinality is same. Like let A be A and B be two sets. Then A is equivalent to B if order of A is equal to order of B. Equal set. What are the set? What has a special property of two sets that they can be equal? Let A and B be two sets. Then A is equal to B if they will be equal if X belongs to A implies X belongs to B, and if X belongs to B, then it implies X belongs to A. So it is the if and only if property. For example, A is equal to 1, 2, 3, 4 and B is equal to 1, 2, 3, 4. In general language, we can easily see that A is equal to B, but in this particular definition, how we define it? Let X belongs to A. So take any of the element, like 3, we have put 3. Okay, so we will see if it is belongs to B or not. Yeah, it belongs to B. 4 belongs to B. 1 belongs to B. So it means X belongs to A implies X belongs to B. But what if we take the element X from B? So yeah, if we are taking also from the B, so if 1 belongs to B, then 1 belongs to A. 3 belongs to B, then 3 belongs to A. So It is the if and only if, or x belongs to A implies x belongs to B, and x belongs to B implies x belongs to A. So this implies A is equal to B. Okay. Also, there is a one result that equal sets are always equivalent. Because if A is equal to B, this implies cardinality of A. It means the number of elements in A is equal to number of elements in B. Easily you can get the result. But what happen if two sets are equivalent? So they will equal or not? Then it doesn't imply A is equal to B. For example, A is equal to 1 2 and B is equal to 3 4. A order of A is equal to order of B, but A is not equal to B. Got it? So the next one is universal set. So what is universal set? A set. So in this set, all the other sets contained. Universal set contain every another set. Okay, a set containing all sets in a given context. What is power set? So power set is a set which contains all the subsets of a given set. Okay. For example, let A is equal to 1 and 2. So what is the power set of A? It is as a set of all the subsets. So what will be the subsets? So in the very next I will define the subsets, but here for example I will define. Okay. So subsets are the all the sets in which the elements belongs to A. Okay. So here what will be the subset of A? So there is a set 1. Okay. There is a set 2. There is set 1 2. And there is a set 5. You can easily see 1 2. Okay. So it is a subset. This is also subset, this is also subset, and 5 is also subset because every element of 5, there is no element in 5 which is not in A. Okay. If A is equal to empty, then power of A is also empty because there is no element, so power of A is obviously empty. It has only one set, that is 5. If A has n elements, then power of A is always equal to 2 raised to power n. That is, if A has 2 elements, then power set of A will always equal to 2. Okay. Now we will define subsets so that you can relate with this. In broad terms, you all know subsets, but in mathematical term, I define. Let A and B be set 2 sets. Then A is the subset. We call it is subset of B if X belongs to A. This implies X belongs to B. For example, A is equal to 1, 2, B is equal to 3, 4. Then A is not subset of B because 1 belongs to A and 1 doesn't belongs to B. Some of the results: every set is subset of itself. So every set is subset of itself, as we can easily see. This is because, like, if X belongs to A, then it is obvious that X belongs to A. Like A and A we can see as two different set, and if X belongs to A, then X belongs to A. It is obvious. So A is contained in A. A is a subset of A. It is very obvious. Second result is empty set is a subset of every set. So in this context, there is no any element belong to empty set that is not belongs to A. So it is also obvious that phi is the subset of A. The third one is, so we have defined the subsets. So tell me total number of finite set containing an element. How many it can have? Finite subset. So we have already defined it as 2 raised to power n. So yeah, so it is 2 raised to power n. So let us discuss about Venn diagram. So it is a graphical representation of sets. For example, union is equal to 1, 2, 3, 4, and A is equal to 1, 2, 3, and B is equal to 1, 2. So how we will represent it as Venn diagram? So it will look as like the universal set we will always define by rectangle. Okay, this is U, and in this there is a set called A, and B in B all the elements of B is in A, so it is a smaller part of A, so it will be as B. Okay, so let's discuss about some operations. Operations on these sets. First is union. Let A and B be two sets. Then X belongs to A union B if this is union. So if there is an element X that belongs to A union B, when it belongs to, what is the special property it has to be in A union B? So the special property is X will X either X belongs to A or X belongs to B. Like A is equal to 1, 2 and B is equal to 3, 4. So A union B is equal to 1, 2, 3, 4. So it contains all the elements of A and B. It is not necessary that the element like 2 it must be in A as well as in B. It can be either of the one of the two sets, right? But it is opposite with intersection. So X belongs to A intersection B if and only if X belongs to A as well as and X belongs to B. If we put this as 1, so uh, in two of the sets nothing is common, so it is obvious that A intersection B is equal to empty. So I think you understand very well that in union the elements must be either of the two sets, but in intersection elements must be in both of the sets. There is a different term, disjoint set. As we can see here, there is no common element. Hence, it is called disjoint. So the disjoint sets are the sets. So the next one is difference of sets. So A and B be two sets, then the difference like A minus B is the set of all elements that belongs to A and the condition is X doesn't belongs to B. For example, A is equal to 1, 2 and B is equal to 2. So we eliminate all of the elements of B. So what is A minus B? It is 1 and 3. So next one is symmetric difference of two sets. So we define it as A delta B. And what is this equal to? It is a union of two set A minus B and B minus A. This implies X belongs to A delta B if and only if X not belong to A intersection B. For example, A is equal to 1, 3, 2 and B is equal to 2. Okay, so what is A minus B? A minus B is 1 and 3. And what is B minus A? It is like, so we have to eliminate B, we have to eliminate all the elements of B which is in A. So 2 belongs to B, but 2 also belongs to A. So we have to eliminate 2 also. So what we get? We get only empty. So what we get? We get A minus B union B minus A is equal to 1 and 3. You can easily find that none of the element belongs to A intersection B, because A intersection B is equal to 2 and 2 is not in the particular set. So I hope you got it. The next one is complement of set. Let A be a set. So the complement is A complement, or we can easily define it as A dash. So what is A dash? A dash is a set of all element that is not in A. So it is a set of all elements X that belongs to U union such that X not belongs to A. Okay.